Good morning. In this lecture series, we see about how the FEA is working for the different types of methods. Okay. And in last class, we were discussing about what is the Rayleigh-Ritz method and the Galerkin method. Now we're discussing the example problem for the each case. So first of all, we go for the finite element analysis. It is a numerical techniques for finding the approximate solution using the given boundary conditions. So what is the descriptions of the FEM? The FEM is a give approximation solution of the given problems. It is done by dividing the given model into the smaller bodies and then perform the analyze. This is called as a discretizations. The connecting the points of these bodies are called nodes. And the accuracy of the solution depends upon the size of discrete body. It is called as a fine discretization would give accurate result. The primary unknowns are displacements from which we find the secondary unknowns, which are the stresses. Yes. So next we have to certain comparison I have to give for the FEA method. The first one I have to represent the each column is like a serial number and direct approach, variational approach, and weight residual approach. Okay. So the variation approach is coming under Rayleigh-Ritz method, and weight residual approach is coming under Galerkin method. So the first of all, the approaches can be using only for the relative simple problems. This approach can be used for the non-linear problems. So while taking the non-linear problems, we will go for the Rayleigh-Ritz method. And if you have a non-linear or non-structured problem was achieved by the method of weight residual method. It's a short form we call it as a MWR. In direct approach, we can directly write down the element equation through the physical reasons. This is the direct approach, and they are using the variation approach. Approach lies on the calculus of the variations and involves the extremize the functions. But weight residual method, it does not rely on the variation statement. This approach is required in the order of to generate the necessary and sufficient number of the simultaneous equation to solve for the approximate solutions. So then direct method is using for the one-dimensional cases like a straight element, like straight bar and a straight beam. But in a variational approach, it can be used for the three-dimensional problem for the complex shapes. But in a weight residual, it can be used for the three-dimensional problem, which can not even be solved by the variational approach. The fourth one, the one-dimensional element or the simple enough that the characteristics matrix and the structural stiffness matrix can usually be formulated by the direct method. For the Rayleigh-Ritz method, for the complex geometries and the curved surface, this the characteristics matrix cannot be obtained by using the direct method. Therefore, the variational approach is used. For the weight residual method, for advanced types of the problem, where the applications of the variation principle is limited, is like the MWR, the was found to be a provider, the ideal theoretical basics for the much wider basics of problem as opposed to the Rayleigh-Ritz methods. And the last final one is the direct method used to determine the behavior of the determine the behavior of the through the matrix algebra, but it is a symmetrical procedure to produce the more general finite element approximations that produce the required only that a functional be available. So the weight residual method is going for the functional needed for the variational approach is cannot be written for the every degree equations. So for example, the Galerkin method we set as a GM. It is a way to formulating and the approximate solution when unknown the degree of DE, but it's not a functional. Yes. So what is the idealizations for these cases? So for ideal cases, the mathematical model is very important for the FEA problem analysis. A model is a symbol, a device, but it to the simulate and the predict the aspect of behavior of the system, the abstractions of the physical reality, the abstract physical realities. What is the impact versus explicit modeling? The implicit modeling, they consist of using the extent pieces of abstraction and filtering them into the practical situation. For example, if you're going for the general purpose FEM programming, and the explicit modeling is a consist of building the model from the scratches. And discretization is one of the main important concepts for the FEM problem analysis. The first one is we defined as a finite difference discretization. The second one is called as a finite element discretization. So the first one we go for the finite difference discretization is the solution is discretated, stability problem, and losses of the physical meaning. But if you go for the finite element discretization, the problem is discrete. The physical meaning is conserved on the elements, the interpretations of the control is easier. And if going for the solutions, the linear system solution algorithm, either going for the Gaussian elimination method or fast Fourier transformation or relaxation techniques. The second one is error estimation and the coveraging analysis. And coveraging analysis. The next class we discussing about the further topics of FEA analysis. Thank you.